Well, first of all, I would like to say hello to everyone and welcome them to our first cross-chapter meeting. The first thing I want to do is to thank our colleagues from the Baltic, especially Adam, our the Baltic president, and also Krzysztof, who was the former president of the chapter that got in touch with us. And also I want to thank Axel Sima, who is our advisor from SGA. I thought he couldn't come, but I see that he's in the chat right now, so thanks a lot, Axel. He worked a couple of years on the Baltic Student Chapter, and he made a bridge between them and us. So it's great that we have him here. Also, I'm very happy to have this opportunity. We are a young chapter. We just started last year, and it's great to have this kind of activities with more established chapters like the Baltic, and I'm very proud of that. And also, I'd like to thank our exposers. There are Daniela, Ariana, and Sofia, that they took the work to make our presentation and to represent not only our chapter but our entire university. So I want to thank them for all that, and thanks a lot to everyone that came here, and I hope you have a great evening.
Okay.
Thanks, Pablo. Well, finally could speak a little bit, but yes, I wanted to thank both of you and Krzysztof, of course. It was a really nice time during my Baltic chapters, my Baltic student chapters times during my masters in Finland, and now I'm really happy to see you guys working together and well, building some bridges and coming to on this event. So good luck, and well, we are all eager to hear and see what you have to present. Cheers.
Okay. Pablo, thank you first of all for reaching me out, and special thanks to Chris and to Axel for coming together and basically kickstarting this presentation. From my side, I'd like to thank Carolina, which is next to me, and Konrad, which is further next to me, for helping me to prepare that presentation. And Chris, thanks again for the photos and for some materials for the presentation. So, and also Carolina made a poster, and we're all grateful for that.
I'm grateful.
All right, lovely. So I think we can commence with our presentation. If that's all right.
Yes, please, of course.
Okay. Does it work? Can you see the presentation and hear me?
Yes.
Perfect.
Okay, great. So, geology of Poland. Poland is a country which is obviously in Europe, somewhere here. It's located on a junction of three major geological provinces, which is the northeastern part of our country is as part of Eastern European Craton, which is composed of mainly very old crystalline rocks. Next to it is the central western Poland is part of a Paleozoic platform, and the country south is occupied by Carpathians and the Carpathian Foredip, which is located somewhere here. And most of area of Poland is covered by quaternary and tertiary sediments, because because of the glacier, Scandinavian continental glacier, which visited us many times, and those lines represent actual boundaries of intervals of several times when the glacier visited us. So I'll briefly discuss. Oh, sorry. Yeah, someone wants to join, and I actually want to accept it. Yeah, back to presentation. Okay. So as I said before, that Precambrian platform is composed of crystalline basements, which is gently dipping towards southwest. The Paleozoic platform consists of consolidated Paleozoic rocks and Permian Mesozoic platform cover. The igneous metamorphic Sudety Mountains and four Sudetic block on the southwest of Poland are part of Pariscan origin, which is located at the junction with the borders of Czechia, Czech Republic, and Germany. So here. And Upper Silesian Basin, another quite important part of Poland, especially for economy, because this is where the major deposits of coal and also zinc and lead are located. Holy Cross Mountains are mainly built of lower and middle Paleozoic clastic and carbonate rocks. And finally, Carpathian origin, which is part of it consists of thrust and fold belts of Cretaceous and Paleogen flysch rocks. It's part of Alpine orogenous, I believe. And the bulk of Polish lowlands, which would be like three-fourths of Poland, is covered by thick epicontinental tertiary sediments, which rest on Mesozoic platformal rocks, many of which are carbonates. Okay, main mining districts in Poland. So despite the fact that Poland has mineral deposits, the mostly known are copper, silver, probably coal, which we have a lot, and zinc and lead deposits. Most of our deposits, documented deposits, are actually industrial minerals, such as gravel, sand, limestone, granites, basalt. Thanks to that aforementioned tertiary sediments, and additionally, on the region of Sudety Mountains, and it's called the region somewhere around there. It's called Greater Poland. We have some hydrothermal water occurrences, but they don't have big economic value because they're not very hot, basically. Okay, and now Carolina will tell something about hard coal.
Yes, so the Polish hard coal is, these deposits belong to the Carboniferous Euro-American coal province, which is divided into two basins, the Paralic coal basin and limnic basins. And Paralic coal basin originated near the sea in depressions along the front of the Variscian fault belt, which was forming in these times, and limnic basins, the limnic basins with coals accumulating in closed basins and intermediate depressions with disconnects and internal rivers. And the most important coal basin in Poland is Upper Silesian Basin, marked here. And this area, well, the operating coal mines are situated, like the main coal mines, except one, Bogdanka, where is located in Lublin Basin. This area of Upper Silesian Basin is estimated to about 5,060 square kilometers, and it holds about 80% of economic resources in Poland. Okay, so the resources of hard coal are shown right here on the diagram, and anticipated economic resources on the end of the 2016 totaled almost 60,000 million tons, so it's very big. And the energy costs today represent here 3/4 of the resources, and coke coals about 25%. And the other type of coals, it's 1.35%. And the reserves in the active mines are about 3,000 million tons as for today. And moving on to the lignite or brown coal, we have some deposits here in Bełchatów, the largest, Konin Adamów, Gubin, Bogatynia, and Legnica. But the most important is the Bełchatów one, because it has almost 60% of lignite outputs. And the coals here are Tertiary age, and they form seams or lenses that are a few meters, dozen to dozen meters thick and really long in shape. And the deposit is mined using the open pit mine, where the overburden is often rather thin, so it's easy to access the deposit. And the production production of brown coal lignite is similar to hard coal, which is about 60 to 70 million tons per year. And here we have some pictures from the Bełchatów mine. So the top left, the open pits, the power plant, yeah, and some machinery that is used to extract the coal from the open pits. And here we have oil and gas. As you can see on the map, the oil and gas deposits are mainly occurring in the south and southeastern Poland, or west and northwestern Poland, and also on the Baltic Sea. Most of them are really they don't extract so much gas and oil. The deposits are rather small, and yeah. So here we have the power plants. This is from Lubiatów, and I believe this is somewhere between these two. This is the largest, can I say, mine for oil and gas in Poland. And here's some machinery from PGNiG, which is the biggest Poland firm that extract oil and gas. And here we have the machinery that was used 100 years ago to extract the oil from the first oil deposits in southeastern Poland. And a bit of history. The old field in Bóbrka in southeastern Poland was not open until 1854, when the oil field was established, and there began the industrial exploitation. and now it became a museum, and the museum is located in the oldest oil mine, which is still operating. And the founder of this idea was Ignacy Łukaciewicz, which was the Polish pharmacist that first distilled kerosene from crude oil and used it to lighting, and introduced the first modern street lamp in 1853, and constructed one of the world's first modern oil well, and built the world's first oil refinery. Sulfur. So actually, Poland has very big sulfur deposits. It's probably like the biggest deposits in the world, I believe. And it occurs like in Carpathian Foredeep, here in a small square, and it's in the southeastern part of Poland, as you can see. Sulfur is occurring here in the form of fillings or fissures and small cavities formed in tertiary rocks from Miocene to Tartan, and mainly these are post-gypsum limestones. And the content of sulfur here is up to 70% at the most, and the average is from 25% to 30%. And here on the map you can see the Osiek mine, which is still active, and I will talk about this in a moment. And here are some pictures of sulfur that was extracted in Poland in Carpathian Foredeep. Yes, and the biochemical stratiform of sulfur deposits. The origin is related to reduction of gypsum by microorganisms and in the presence of hydrocarbons. So the first step was the sedimentation of sulfates like gypsum and anhydrite, that they were covered with impermeable clays. And then tectonic movement created pathways for migration, and the reactions between methane and calcium sulfate from gypsum was accompanied by microbiological activity that produced hydrogen sulfide and carbonates, and microbiology activity produced elementary sulfur then and water. So that's how the deposit was originated. And the Osiek mine, as I told, this is the only open sulfur mine in Poland, and sulfur is extracted here using fresh method, where you pump very hot water into the deposit. The water melts sulfur, and then the molten sulfur goes out. And Poland was one of the world's largest producers of sulfur till the 1980s. And however, the growth in the recovery from natural gases and crude oil caused a significant decrease in importance and value of native sulfur deposits. As we know, now sulfur can be extracted from coals, oil, for example, and gas. And now it's time for Konrad. Okay.
So it's my turn, and I would like to say about something about salt in Poland and copper. And let's start from salt in Poland. The salt in Poland comes from two geological periods, and as we can see on the slides, it's Czechstein and Miocene. The Czechstein salt occurs on a vast area of the country, and And this is the examples of working mines like Kłodawa, Mogilno, Góra, and Sieroszowice. And it's located, I think, in central part and northern part of Poland. Next, it's Miocene. It's occur in Deep Carpathian, and it's a very famous part from Poland in historical time, where in famous Bochnia and more famous Wieliczka, historic mining, King's historic mining was the had a really influence of early Poland economy, and that two mines is huge tourist attraction and are listed on UNESCO Heritage List. As we can see on the left down picture, we had a chapel from underground for miners. And next is copper deposits. It's one of the most important deposits in Poland that marked Legnica Glogów copper district in Forsythetic monocline. But copper is in history mine from, for example, Holy Cross Mountains, like, oh, I don't have a mark. Oh, yes. Here and Sudety and Tatra Mountains. So for now, it's the most important, as I said before, is Forsythetic monocline in Legnica Glogów copper district. This is the quick map about a field of that copper district. We had 5 districts, like, for example, Sieroszowice, Rudna, Polkowice, Lubin. And Lubin-Sieroszowice is the largest sediment-hosted strata-bound copper deposits in the world. So deposits occupies area about around 500 square kilometers, and mineralization zone is on depth in range from 400 to 1,400 meters, and it inclines some 2 to 6 degrees on northeast. And something about the deposits. It's sediment-hosted stratiform copper deposits. In other way, Cooper Schiefer type. It's come from our neighbor Germany, when that deposits is. And mineralization occurs in 3 types of rocks: in sandstone, shale, and carbonates, and the most and mainly is sandstone. And thickness of that zone varies from a few to 20 meters, for example, in Rudna. And average content of copper is 1.8%. So here we had small profiles that copper deposits come from Permian. I'm sorry. It's on the boundary between Rotliegend and Zechstein. And something about that deposit. It's, as I said before, structural control. That's it starts from no structural controls to highly structurally controlled along faults. Deposit morphology is stratiform, but it's strata-bound and stratiform bodies, and mineralization cross-cut bedding at a very low angle. It's a little obvious alteration, for example, hematitic alteration, and chemistry of fluids with produce that deposits, and that fluids was low temperature, oxidized, and chloride rich. And precipitation due to reduction of our solution by organic matter or natural gas, or by reaction of our fluids with carbonates or sulfates. And source of fluids was diagenesis of arcosic sediments and mafic volcanic rocks. And from that deposits, we had 140 minerals known from Elgon, like chalcocite, digenite, tennantite, chalcopyrite, bornite, tuholite. And many commodities are copper and argentum, but also ran, gold, platinum, etc., etc. And we had a amount of resources. It's about 30 million tons of copper and 90 million tons of silver, and annual production is about 32 million tons of ore, which 1.5% of copper, 36 gram per tons silver, which equals to 480,000 tons of copper, 1,500 tons of silver, and 350 kilograms of gold. And additionally to deposits I taught before, in Polkowice is 2 salt extracted. So here is a few photos from mine, from underground, and here I take a photo because in that mine between 4 where it's mine, you can reach by, for example, that cars. And Iron Bridge is the place where the Genju rock, Genju minerals was collected. It's the largest tailing pond in Europe and occurs about 1,400 hectares area. And the last, what I want to say to you, it's copper deposits called Myszków. It's porphyry type, which occurs in the form of stockwork with small veins, where the host rocks are granite, porphyry, schist, and metamorphic rocks. The mineralization is mainly chalcopyrite, scheelite, molybdenite, and galena, and it is polymetallic deposits with molybdenite, copper, and wolframium. That deposits, which is in that place under the Częstochowa, it's actually not exploited. And I would like to give the voice to Adam.
Okay, yeah, sure. Thank you. Zinc and lead. So, zinc and lead are elements which often occur together. And zinc prices actually recently skyrocketed to the prices over $4,000 per ton. So basically, there are a couple of projects which are restarted in order to look for zinc, and I believe that investors might look at Poland right now because we still have some zinc left in our deposits. As you can see, zinc is mainly used in anti-corrosion alloys and fireproof fabrics and in pharmacy. And lead is mainly used for car batteries and things such as X-ray protection shields or ammunition. And as you can see, those metals are getting more and more expensive day by day. All right, and geological location of Polish zinc and lead deposits. So the deposits are located, related, sorry, to carbonate rocks formed on a Silesian crack of upperlands, which is a region with many carbonate rocks, which sedimented during the Jurassic, Triassic, and Cretaceous era. And as you can see, there are many faults here, which would be handful for example, mineralized fluids to get through, which is significant because profile looks like this. And of course, I forgot to mention that these deposits are MVP deposits, so Mississippi polytype, typically hosted within carbonates. And their metallurgy is very simple. So basically, in that deposit, we won't find many additional elements. It's mainly zinc, lead, some iron, cadmium, but for example, in sphalerite, we often come across indium, gallium, germanium, but those aren't here at economic values. And even though the rock hosting zinc and lead mineralization ranges from Devonian to Jurassic periods, the economic value deposit is hosted within that ore-bearing dolomites, which is muschel kalk of Middle Triassic. Bitom districts. This is the district of historical exploitation of zinc and lead ore, and back then it was easier to extract and mine calamine ores. So they consist of zinc oxides, not sulfides, like sphalerite, for example. And they were exploited until 1950. As I mentioned, they are mainly calamine ores. And they, so for example, on the left, we can see regular sulfides, probably galena, sphalerites, wurtsites, outcrop. And this is how those calamine or galmany, Polish, ore looks like. And recently, I've learned during my practice, I've learned a very neat trick how to quickly determine whether we have zinc or not. So there's the combination of two chemical agents called zinc zap, and it enables you to quickly make a droplet on a rock, and if this is calamine, it will immediately turn bloodish red, like on a photo. And if you have calamine, you probably had sulfides, so you're on a good path to finding some zinc. Okay, we'll go to Olkusz district, which is on this map. It's here, and the reserves are quite big. I mean, they were quite big, over 250 million tons. And this is mainly deposits hosted in the same type of dolostone, actually, dolostone rock. It's quite large because the area of it is dozens of square kilometers, and it's relatively shallow. So access to the mine is via dip roads. So they don't use shafts; they use cars which drive to the mine. The ore bodies are mainly strata-bound and nest-like karst breccia, and they occur from 40 to 240 meters below surface. And the average content of metals in sulfide ores is usually ranging from 2 to 4% of zinc and 1 to 2% of lead, which isn't super high, but it's definitely was economic. Because, for example, in Spain region, same MVT type of deposits reach up to 8 or 9% of zinc. So, and there's a production of this mine, 50,000 tons of zinc and 13,000 tons of lead were produced, which is 24% less than in 2016, because right now the mine is completely shut down. It's flooded. So it's not operational anymore, but it was producing a fair amount of zinc and lead, mainly for European use. And this is the picture of a machine from underground. And Olkusz, as many MVT type mines, so to say, had a water issue because they had to drill special galleries in order to dewater the mine, because there was plenty of water going through. I found the information that they were pumping out 50 cubic meters per second to the surface. It was multi-stageal mineralization, and on this chart you can see that deposit wasn't super rich, but it was relatively big in comparison to other MVT zinc and lead deposits on the world. Okay, so what's in there actually? Those are samples of the ore. This is the collapse breccia, which I mentioned, and it consists of dullstone banded with sphalerites actually. And on the right we can see famous zinc blende or Schalenblende from German, and it consists of concentric layers of zinc, quartzites, probably some galena here, and marcasites on the top. And as I mentioned, trace elements in the sphalerites in the ore weren't considered of economic value. All right, and this is a photo which Krzysztof sent me today. It's a very big Schalenblende. It's really good specimen, only worth a lot of money right now. Nickel, so-called Szklary Massive in Lower Silesia, is a region. It's a region in Sudety Mountains, which is famous for occurrence of chrysoprase as a stone, which looks like this. But back to the nickel, because it was mined back in the day, and the ore was so-called saprolite. Yes, saprolite ore of nickel, because it consisted of weathered serpentinite, which derives from mafic or ultramafic rocks, which have nickel in them. Resources are estimated and around 117,000 of tons of nickel. And the deposit dimension was 5 by 1 kilometer and thickness of 40 meters. And it had 0.18 to 0.5% of nickel in it. It was exploited till 1983, and deposits formed lenses or nests or veins located along fractures and faults along the massif. And as you can see, the another graph, that dramatically rising price of nickel might also trigger some response from investors for nickel exploration project. And chrysoprase, which I mentioned. It's a green variety of chalcedony. In serpentinate weather, it forms veins of small thickness, like 1 to 5 centimeters, and often passes into ordinary chalcedony without intense green color. And obviously, the most valuable are those with vibrant green, but they're extremely rare. Here you can see how those chrysoprase veins look in saprolite, probably nickel bearing, and this is the flooded adits of nickel mine. All right, and this is the last slide, I believe. Kletno was a mine. Kletno, Kowary, and Radoniów in Sudety region as well. It's that metamorphic region, so there's a lot of very interesting rocks here and interesting mineralization. Kowary and Kletno were secret Russian uranium mines in 1937 until 1953, I believe. So they began to produce uranium after the war. And in the reports, the miners and the staff of the mine, they couldn't use the word uranium. They had to write metal, and uranium was taboo word in general. They didn't get much ore from that mine, but a couple of years after ceasing uranium excavation, they actually switched to fluorite mining, which is the specimen here. And today there is a competition on that fluorite heap called International Championship in Mineral Hunting. So it's probably hosted annually. Well, it was hosted annually because due to COVID, there are some restrictions. And richest mineralization was hosted by metamorphic rocks such as quartzites, marbles, and magnetite hosting amphibolites. Because the Kletno, before it was considered uranium mine, it was actually the iron ore mine back in the days before the war. I believe with this slide we covered most of Polish deposits, bigger and smaller ones, and I think that's it from our side. Thank you very much for your attention.
Thank you, Adam. Thank you to all you three. That was a great presentation. I'm eager to go to that award hunting cup that you have there to get some fluorite. That was a great presentation, and I really appreciate it. I think you have some questions on the chat, so if you would like to ask the easy ones, just the easy ones.
Oh boy. Okay, so we'll start from Leslie. Why is it called the Iron Bridge? Frankly, I have no idea.
It is just called that,
it's just the large container of tailings from. Maybe Krzysztof knows the answer.
Maybe I can help you. It was named after the village, which used to be in place of this area. So it's just the name of the local village.
Okay, great. Thank you for that. Okay, other questions? Any troubles with?
Maybe I can help again. So in this area, there is no problem with LTO license to operate, because before the copper district was established there was only very small villages in this area. So the people, they understand that the cities there, they will build because of the mining, and most of the people who live there, their job is connected to the mining. So they are okay with the mining, and they know they benefit from it. These areas are one of the richest in Poland, so I would say that there is no problem with community in this place. But for example, the area with zinc deposit, MVT deposit, there's one big deposit basically under the big city, Zawiercie, and the people they don't want mine there basically. So I can understand that they are worried about the potential problems with water and with mining. Some part of the land can subsidize, but some arguments are ridiculous. Like they say that they don't want any uranium mining there, but there's no uranium, it's just zinc and lead. So basically that's it. Maybe I can also answer the next question about the tectonic environment of the copper system in Poland. So in terms of the Kupferschiefer, let's imagine in the Carboniferous period, the end of the Variscan orogeny. We have the continent-continent collision, we have end of this orogeny, and then in the foreland of this orogeny, we have substitution, basically passive rifting. We have accumulation of thick layer of sediments, and then it was flooded by the Zechstein Sea. So basically we have the continent-continent collision, and then we have passive rifting and formation of the basin there. And basically that's it. And then we have later inversion of this basin. Basically in the during the Alpine orogeny, we have the reactivation of the older faults, but we have no longer extension, but closure of this basin. So I think that's it. And about the sulfur, I think it's the thing is that the sulfur, I think, is quite pure, so it has some special utility for example, for some kind of pharmaceuticals or for chemical industry.
Well, I found the file that actually shows that we export the sulfuric acid mainly to Germany, and the sulfur, in its original form, it's mainly exported to Romania. But the sulfuric acid export is much, much, much bigger.
Okay, thank you, Krzysztof, for aiding us with the questions. Much appreciated.
Sorry, Adam, I was out for a while. Did you answer the question about LTO related to KGHM?
I believe Krzysztof answered.
Sorry, Krzysztof.
Yes, basically there's no problem, because in this area there was not many towns or cities before the mining started. So the people, they realized that the area was developed because of the mining, and they are fine with it. They understand that their wealth, this area is connected to the mining. Most of them, they have job, maybe not in the mine, but related to the mining. So they are quite okay with it. They are happy.
Cool.
That there are new shafts, new mines in this area. So there's no problem with the community, I would say.
Similar to Finland, or what happens in Czech Republic, in Erzgebirge, or in southeastern Germany, in Freiburg, right? Tradition comes first, I guess. But well, you have to be aware of this green wave that tries to put some sticks on a bicycles, for example. But yeah, thanks, Krzysztof.
Well, guys, I wanted to ask you about the energetic matrix that you have in Poland. Does your matrix depend on carbon and oil, as you said, or do you have nuclear energy with all these uranium deposits?
No. We're mainly dependent on hard coal and lignites. I believe the Bełchatów mine provides 1/5 or something.
30%, I believe, it comes from Bełchatów mine.
I mean Bełchatów power plant, because lignite mines are very close to the power plants. They even have conveyor belts which links the two in order to quicker deliver coal to the power plants. And there is there is nuclear program in Poland, but actually after Chernobyl accidents, we have really anti-nuclear environment here in Poland, and people generally they slowly convince towards nuclear energy, but yeah, it takes enormous amount of money to even start doing this, and you have to convince people which aren't always okay. It's getting better, but right now we're dependent on coal very much.
But KGHM had a special program, I think it was around 1 year ago, and in that year, that's called small nuclear reactor from USA, I think. And that reactors, I believe it's not for a domestic, for a public energy, but in my opinion, for company energy, what they want.
Yeah. So those small reactors are mainly for industrial use, like for smelters, which requires a lot of uninterrupted flow of energy. So that'd be for them. But yeah, right now we have coal power plants, which emits tons of CO2, and that's not too good.
Yeah. And how about the new the new energies like wind and solar energy? Do you have some kind of development on that matter?
Well, we have some, like many wind energy comes from the areas near the Baltic Sea, where the winds are stronger. And if it's about water, it's really depends on the water flow, and Polish rivers don't really have that high water flow to produce energy. So it's mostly in small mountains, rivers, and it's more like a local use and not on a big scale. But we have some water power plants, mostly also near the Baltic Sea area. And if it's about solar power, I believe in Greater Poland we have more and more solar farms, and right now I read that many communes are switching to local solar power plants to provide the energy for the municipality. And yeah, but it's also very small use. You can also have your private solar panels on your roof, but it's still a very small percentage of people who do that actually.
Okay, great. Well, thank you for
Maybe one interesting point I can add.
okay. So
We have also they mentioned about the salt deposits, and there are salt diapirs in Poland, and some of them they built a big magazines for gas, for example, or for oil. So they leach the salt, and they build a huge cavern inside this salt diapir, and they pump the gas. So it's like a reservoir for gas, so it's quite important, like the situation we are right now. So it's just one thing I wanted to add.
Do you think, Adam, Krzysztof, that nickel and platinum deposits are gonna get more attention now with all these sanctions? I mean, some major companies going for them in Poland, considering its friendly investment environment towards mineral deposits. Or I don't know about size.
I'm not sure about Polish companies, but I think some Irish and Australian exploration companies are currently interested in those nickel deposits. But maybe Chris, you know more details?
Yeah, it's just like I think it's too small. Basically, in Poland, it's too small. But like in the context of the whole world, I think that a lot of these lateritic nickel deposits, so like Indonesia, Philippines, they will be quite hot topic in the future, especially if the method of processing these ores will be. I heard there are some breakthroughs, so this method will be improved. I think this will be the way to go for the mining companies in terms of nickel, at least.
So you believe, Krzysztof, that right now it's about half and half, like ore coming from weather deposits and the other half coming from layer mafic intrusions or magmatic deposits. Do you think sedimentary deposits are going to gain some more market towards the hard rock ones?
Maybe, who knows? And there's also one interesting deposit in Zambia. It's called, I think, Enterprise. It's basically the same type deposit as Kupferschiefer, but instead of copper, they have nickel. So that's some curiosity. So it's also a question, maybe there's more like Kupferschiefer type deposits, but with nickel instead of copper.
Interesting.
Well, great. Thanks again to you all for the presentation. It was very good, very easy to understand. Even we are talking in a language that isn't ours, neither yours. So that's great. I think we should go on. We can start with our presentation.
Yeah.
Okay.
Yes, I'm going to present. So this is us. We represent the National University of Córdoba. We are Daniel Alonso, Arena González Vidal, and Sofia Rico. Okay, in order to talk about mining activity in our country, it's necessary to take into account some geographical, cultural, and political aspects. To the west, we have the Andes mountain range, while to the east, we have plain with modern sediments. These gritty conditions, the provinces that have mountain ranges, providing greater metalliferous resources, while to the east, agricultural and livestock activity predominates. Before the 1990s, there was little mining activity, but in the last 30 years, there has been a remarkable growth. So considering 36 of the most outstanding deposits, 53% of them are epithermal, 22 are porphyries, and 14% are evaporites. And this graphic shows those who are the percent that are active. These three typologies. First, I'm going to talk about the evaporites. Lithium comes from two main sources, from brine and hard rock. Brine deposits are found in salt lakes where lithium is extracted through an evaporation process. Brine harvesting is historically a simpler, more common method of extraction, but generally yields lower grade lithium. The most famous area for lithium is known as the Lithium Triangle, located in the border between Chile, Argentina, and Bolivia. About 58% of the world's lithium resources are found in these three countries. With reference to Argentina, lithium exploration started in 2008, and only large projects have been developed. To give a brief overview of the 2020 production, Argentina is the fourth largest lithium producer and extracts lithium carbonate. the genesis, several authors postulate that soluble salts absorbed on neo-tertiary and quaternary pyroclastites linked to volcanic calderacs contribute lithium and others like boron, potassium, and magnesium to the hydrogeological circuit. They propose a shallow saline lake model, which received contributions from surface, groundwater, and minor thermal springs too. Mank and colleagues here identify 6 main characteristics that guides. 1, an arid climate. 2, a closed basin containing a salar or saline lake. 3, an associated igneous or geothermal activity. 4, tectonically driven subsidence. 5, suitable lithium sources. And 6, an ample time to concentrate brine. But how is held the extraction process? First, boreholes up to 200 meters deep are drilled to extract the brine. Then special pumps are used and are transported through pipes to an evaporation ponds. Here we can see. The brines, they are left to rest for 18 to 24 months, so that the action of the sun and the wind evaporates the water and the salts concentrate and precipitate. Brines rich in lithium carbonate are extracted, purified, and sodium carbonate is added to generate lithium carbonate. In terms of production sites, Argentina has 2 commercially operational salt flats in the provinces of Catamarca and Jujuy. In Catamarca, there is Salar del Hombre Muerto, and in Jujuy, Salar de Olaroz. Since 2019, many other lithium extraction mining sites have been under construction or in the stage of advanced exploration. In Catamarca, it's operated by the US-based Livent FMC Corporation. It's located at an altitude of 4,000 meters with reserves of 850,000 tons, grade 600 ppm. The life of mine is estimated to be more than 70 years. Regarding Salar de Olaroz, it's operated by Sales de Jujuy in conjunction with Oro Cobre Limited and the Japanese trading company Toyota. It's located at an altitude of 3,900 meters with resources of 1,752 million cubic meters of brine. The grades are 690 ppm of lithium, 5,730 ppm of potassium, and 1,050 ppm of boron. The life of mine is estimated more than 40 years, with a defined resource of only 15%. And now, Daniela continues with.
Well, before we talk about the epithermal and porphyry deposits, I'm going to give a little bit of a geological setting. Their genesis is linked to subduction zones associated with volcanic and subvolcanic rocks. These 2 types of deposit are transitional to each other, especially high to intermediate sulfidation epithermals and porphyries. The epithermal deposits are formed by shallow hydrothermal fluids and host precious metals as gold and silver, and occasional base metals as zinc, lead, and copper. These deposits can be high to low sulfidation. Porphyries are related to shallow emplacement subvolcanic bodies and hosts mostly copper, gold, and molybdenum, among other metals. In Argentina, low sulfidation deposits are the dominant ones, in addition to some intermediate sulfidation. In the volcanic provinces of the southwest of Gondwana, Choyjoy, and Chonaique. These provinces are highly extensional and have a bimodal type of volcanism, which explains this low sulfidation dominance. We also have high sulfidation deposits to a lesser extent, but of great importance due to economic interest, linked to intermediate volcanism of the Miocene arc. Now I'm going to talk about 3 regions that host some of the main epithermal deposits of Argentina. First of all, we have the Seo Massif in Santa Cruz, which has 9 of the 15 epithermal deposits in production of Argentina. These are low to intermediate sulfidation deposits. Two of these 9 deposits are world-class type, Cerro Vanguardia and Cerro Negro. These are low to intermediate sulfidation deposits from the Upper Jurassic, hosted in bimodal volcanic rocks of the same age. Next slide. Cerro Vanguardia is operated by Cerro Vanguardia Sociedad Anónima, which is a joint venture between Anglo Gold Ashanti and Formicruz. It was discovered at the end of the 70s, and it's been in production since 1998. It's a veriform low sulfidation deposit with a bin field of more than 200 linear kilometers of structures. It has several elongated open pits and underground mining since 2010. The processing plant has a capacity of 3,400 tons per day and involves agitation and leaching. The total reserves are 0.95 million ounces of gold and 23.89 million ounces of silver. The life of mine is estimated until 2030. Next. Cerro Negro is operated by Oro Plata Sociedad Anónima, owned by Newmont Gold Corp. It was discovered because of the mining boom since 1993, and it's been in production since 2014 by Gold Corp. In 2019, Newmont acquired Cerro Negro in the Newmont Gold Corp transaction. This deposit is a veriform low sulfidation epithermal deposit with 5 underground mines and a potential open pit. It uses agitation leaching and processes about 4,000 tons per day of rock. The total reserves are 2.57 million ounces of gold and 20.42 million ounces of silver, and a life of mine until 2026. Next slide. Well, the second region that I'm going to mention is Cordillera Frontal, which exposes sedimentary rocks from the Paleozoic to Cenozoic volcanism, but is dominated by Choyjoy magmatism from the Permian and Triassic. There are two generations of deposits. First, Permian deposits related to the Choyjoy group, and second, we have Miocene deposits related to the Cenozoic arc. Here we have a Veladero deposit, which is a world-class type. Well, Veladero is operated by Minera Andina del Sol, owned by Barrick and Shandong. It was discovered in the late 80s, explored between 1996 and 1998, and it's been in production since 2005. It is located in one of the richest epithermal deposit belts in the world, especially high sulfidation ones, that is Paja del Indio or Indio Belt, at 4,000 meters of altitude in the limit between Argentina and Chile. It is an high sulfidation deposit disseminated in predomagmatic breccias and volcanic clastic rocks. The mineralization has a low grade, about less than 1 grain per ton of gold, and it's oxidized and disseminated. This area is still in exploration, trying to consolidate resources to feed Veladero mine from the regional targets and also from potential high-grade deep zones. The mine is composed by numerous open pits, and the ore is processed by lixiviation pipes. The total reserves are about 2.2 million ounces of gold, and the life of mine is estimated until 2030. Then Axel can tell me if it's true.
Yes,
But
also.
well, then we have the third region that I'm going to mention, Puna. It is a high plateau above 3,700 meters above sea level that exposes Cenozoic volcanic rocks. The only advanced epithermal deposit in production in this area is Pirquitas Chinchillas from the Miocene, and it's a polymetallic bolide type. It is the southernmost of the Bolivian tin belt. Next. There. Well, Pirquitas Chinchilla, it's operated by Puna Operations, owned by SSR Mining, a joint venture between Silver Standard and Golden Arrow. It was discovered in the 30s, and the Pirquitas mine was in production since 2009, processing ore from the San Miguel open pit, and concluded mining activities in January 2017. That same year, SSR is formed and incorporates Chinchilla to a project to extend the life of mine. Pirquitas is a veriform intermediate and low sulfidation epithermal deposit with sulfide-rich veins and veinlets. And Chinchillas is a silver, zinc, and lead epithermal deposit located 42 kilometers from Pirquitas and has a total reserves of 47.9 million ounces of gold and 219 million pounds of lead. The life of mine is estimated until 2026.
Now we're going to talk a little bit about the porphyries in Argentina. Porphyries represent 5% of the current mining activity. We are being kind because the main deposit is in a closing stage. But it is estimated that add to the projects in advanced stages, this could represent between 22 and 25% in the near future. So they're going to be very important. Our porphyries are of the Andean type because of the subduction zone. So the metallogeny for this deposit begins in the Permian Triassic with the development of a volcanic province of very important extension called the Choyoi magmatisms. But the most important event occurred in the Cenozoic with the development of the Andean orogeny, which is a metallogenic belt with important hydrothermal systems. This event generates the most important porphyries in Argentina, like Lindero, Bajo la Lumbrera, José María, Pachón, among others. Next. The most important porphyry in Argentina was Bajo la Lumbrera. Bajo la Lumbrera was a world-class copper-gold deposit located in the northwestern of Catamarca province. in the east foothills of the Andes mountain range, and an altitude of 2,600 meters above sea level. Bajo la Lumbrera was very important because that was Argentina's first major metal mine, and it's representative of the gold-rich porphyry copper deposits. It's a really old mine. It was discovered between 1938 and 1945. It was explored until the 88, but the production starts in 1997. When this mine was active, this deposit was one of the 10 largest copper producers in the world and the 14 largest gold producers in the world. The total reserves were like 460 million tons, with an average ore grade of 0.5. The deposit occupies an area about 2 kilometers of diameter and 450 meters of deep. The mining company ceases production activity in 2018 and is currently in a process of closure. Next. Well, aside from these active projects, there are 15 really advanced projects in Argentina in an advanced stage, construction of feasibility. And we can see in this list that 12 of these projects are new discoveries. The most outstanding deposits we can see in these maps are porphyries of copper. The most important are Taca-Taca, Pachón, Agua Rica, and the Pascualama and Navidad epithermals, and the Salar del Rincón and Potasio Rio Colorado. We're going to talk a little bit about these projects and the future of Argentina. Next. Taca-Taca is a deposit of copper, gold, and molybdenum. It's a porphyry system of the Andean type. This project is owned by Canadian company First Quantum Mineral and is located in the Puna de Salta, around 3,600 meters above sea level. This deposit estimated reserves are around 29 million tons of contained copper, representing the 5th largest copper reserve in the world. The production is going to start in 2024. They are awaiting adequate assurances regarding the Argentinian tax regime prior to the construction. Next. Pachón is a binational project. It's called Pachón in the Argentinian side and Pelambres in the Chilean side. It's located in a very active mining province called San Juan. It's located at an altitude of, we can see, 3,600 meters above sea level. This is a porphyry of copper and molybdenum and was discovered in the 1964. The estimated production from this deposit is around 280,000 tons of copper per year, with an estimated life of 30 years. Next. Agua Rica, now called Mara, is located in the same province as Bajo la Lumbrera. It's cogenetic. And in the province of Catamarca, this is like a little bit higher, 3,300 meters above sea level. This deposit is a porphyry of copper, gold, and with molybdenum and silver. The estimated production is going to be around 236,000 tons per year. And it's going to use the infrastructure of Bajo la Lumbrera so they can amortize some costs. Next. Lama or Pascualama is a high sulfidation epithermal deposit and will have been the first binational mine in the world. It's called, we can see that it's called Pascua in the Chilean side and Lama in the Argentinian side. This project is located like 4,500 meters above sea level. It's owned by Barrick Gold. We can see that the estimated reserves were 18 million ounces of gold, 670 million ounces of silver, and 660 million pounds of copper. The construction from these projects began in 2009, but was halted in 2014 due to political and environmental problems on the Chilean side, because the method of gold extraction was using the cyanide leaching, and you can see in this image that there are a lot of glaciers around the project. So this was a very controversial and generate rejection in the Chilean population. So it was sadly on September 2020, the Chilean Supreme Court determined the definite closure of this project. Now the company is conducting some studies to see if it is economically viable from only the Argentinian side that has like 30% of the deposit. So we are going to see in the future if it's viable. This next project is a world class again, but it has troubles. Like this project is located in the province of Chubut. It's a world class epithermal deposit of silver, has more than 709 million ounces of silver. Lead and copper is owned by Pan American Silver, but this is one of the largest undeveloped silver projects in the world because it's located in the province of Chubut, which is a very anti-mining province in Argentina. The laws of this province prohibit open pit mining and the use of cyanide, which will not be used in Navidad, but the project needs an open pit mining for the depth and the orientation of the deposit. Needs an open pit mining, which is not possible right now with the current laws. And the last debate was a conflict over the use of water. These provinces have really trouble with clean water, but this project is going to use a basin that is in the same area as the deposit. And the basin has no related to the Chubut River. Next. We are going to talk about a little bit about the evaporates. This is Salar del Rincón. It's located in the province of Salta. These are brines rich in lithium, boron, and sodium sulfate. The resources estimated for this project are about 1.5 million tons of lithium with a grade of between 400 and 600 ppm of lithium. You can see that the grade is similar, but the resources are much bigger than Salar del Hombre Muerto, which is the largest lithium mine in Argentina. So this project is bigger. The production will start with 1,200 tons per year of lithium carbonate. So it's gonna transform Argentina in one of the main lithium countries. Next. This one is a potassium deposit. It's called Potasio Rio Colorado. It's located in the city of Malargüe, in the province of Mendoza. This is a province against mining, again, so it's really hard to activate these projects. The evaporite is a Jurassic paleo evaporite with two main levels of sylvite. The reserves of these projects are around 2.4 million tons of potassium, with a potential to expand this to 4.35 million tons of potassium. This project was under construction with a plan to start in 2014. It was owned by a Brazilian company called Vale, which stopped the construction in 2015 due to the sharp drop in potassium prices and the company's problems in Brazil with environmental problems. Now the government of Mendoza is seeking the creation of a mining company and is looking for investors, so they will start the production activities. If this project starts, Argentina will be one of the largest producers of fertilizers in the world. Next. We can see in these maps the amount of projects that are in exploration In addition to the 21 active projects and the probably 15 future projects, there are a really large number of exploration projects, around more than 300, which confirm the growth trend in the mining activity in Argentina over the last 30 years, pretty much dominated by hydrothermal deposits and evaporates. You can see in numbers how much this represents in terms of millions of tons of silver and gold. So it's going to be pretty important for the mining activity. This was possible because in the 90s was a change in the mining code, which guaranteed investors tax and fiscal stability, which we didn't have before for over 30 years. So we can see the escalating in the exploration. Mining exports last years were exceed the $3.2 billion. This was 23% higher than in 2020. And this was driven mainly by the significant improvement of gold, silver, and lithium prices. Argentina's economy, you can see, and is very known around the world, is historically based in agriculture and cattle raising. So there is certain resistance from the society or to mining activities. This add to the misinformation of some environmental groups, leads to the fact that different provinces in the country, around the country, have very opposed laws toward mining. You have provinces like San Juan that are really active in mining projects, but some provinces that have banned the activity totally. But in spite of this, we remain optimistic that these projects will see the green light in the near future, because they are very important for the generation of jobs and the growth of the Argentinian economy. So we are optimistic. This was all, so thank you so much for listening.
Okay. Thank you very much for the presentation. And I actually have a question or a couple of questions, but let's maybe answer to the chat questions first.
Thanks, guys. Excellent presentations. I don't know, Pablo, if you can let me answer Leslie's question, which is quite good. The question is, how connected are these areas to post-processing? Do they have to be shipped far to get to refineries? Well, Leslie, this is a good question, because it's actually a problem, especially in the Andes, and especially for bulk deposits such as porphyry copper ones, which involve huge tons of materials. And also, well, these areas are quite expensive in terms of capex and logistics, as you might imagine. You are building mines at 4,000 meters above sea level, and maybe the closest town is 200 kilometers away from the mine. So maybe the easiest solution that you may imagine would be, okay, why don't you move the ore through Chile and get to the Pacific and export to the Pacific? But this is tricky, because usually makes trouble with the working unions that won't allow losing those job positions in Argentina. So for precious metals, it's not a problem, because you can move weekly or monthly production maybe in a suitcase for gold and silver bullions. But for, as I said, for porphyry copper or these brines and, I don't know, lithium carbonates, usually you have to invest a lot of money on building infrastructures such as railways that will allow you to reach the Atlantic or the main ports in the Paraná River, such as Rosario. On the other hand, Patagonia is it's a massive, so it's quite flat, and you can reach the Atlantic ports in Patagonia quite easy. So, but still, it's a really remote area. Most of the Argentina economy and population is concentrated in Buenos Aires, in the capital. So the far interior of the country is quite empty. So yeah, this is a big trouble, especially when considering investment in this project, and that's one of the reasons why many of them, the ones that Ariana, Sofia, and Daniela mentioned, are still not in production.
Yeah, thanks for giving that information. I was kind of figuring out, because it seemed like they were pretty remote. Where I was actually also, a follow-up question was, where's like the nearest major, like if you had a map showing where the ores went to, where would be like the major place that they go to, like Buenos Aires or the first place?
I don't know, Sofia, do you have the map of Bajo la Lumbrera?
Yes.
Or just a country map? So that's a pretty good example, because in Bajo la Lumbrera they had to build a railway towards
this one, or you prefer?
Yeah, that one. So you can see in the map how the pink provinces are the ones involved in the project. The one on the left is the one in the Andes. They had to build a railway towards Tucumán, so as to connect to the main rail system in Argentina, and then the copper concentrate was shipped towards Rosario Port, which is in Santa Fe. So that distance is nearly 2,000 kilometers. And then you have a port there in the Rio Paraná, which then goes through the Rio de la Plata, which goes to the Atlantic. So if you go to Chile, you have, 500 kilometers, but then you have these issues I mentioned before.
Yeah, wow. Tough challenges.
Yes.
Yes, there is like a great controversy between the inner provinces and Buenos Aires about trading. Buenos Aires is like the monopoly of trading. Everything that comes from within the provinces has to go through the Buenos Aires port. So it's been an historical controversy and the development of ports in Patagonia also. But there's like that difference between the provinces and Buenos Aires that make Buenos Aires the leading trading province, and the inner provinces are tied to that relationship, and sometimes they can't develop the activities they want because of this challenge of having to get all their goods through Buenos Aires. So says Krzysztof, could you summarize major similarities and differences between mineral deposits in Poland and Argentina? Well, I don't know if you want to answer.
Yes, I could see that you have a little bit of porphyry, so that could be a similarity. We didn't mention also the uranium deposits. We have a lot of uranium deposits, but I think none of them are being in production. So I didn't mention that. Regarding the differences, yes.
Maybe just a quick answer would be that most of Polish deposits are related to basins. Serex, sedimentary hosted copper, coal deposits are related to basins, and whereas in Argentina, most of the precious metals and base metals are related to subduction and a massive arc as the Andes are. So that's a quick difference, right?
Yeah.
Also, the difference I can see, you have higher grades on higher concentration grades on your minerals. In contrast with Argentina, that we have a lot of tonnage, but we have lower grades. Also in porphyries, we have like 1.2, I think, grams per ton in copper, and you have like 2.5 and 3 grams per ton.
Yeah. So I think the temperatures are also different because for our zinc and lead, the temperatures were really low, barely above 100. I think 150 degrees is the maximum, and in the epithermal and porphyry, I believe the fluids are much hotter, if I'm correct. And
Yes.
actually, I wanted to ask about that open pit mines, because from what I saw, the majority of those mines were open pit, and it's because of that dissemination of useful elements, or for example that it's because the deposits are also rather shallow. Yeah, do you have some underground mining, or it's mainly open pit?
Well, I mentioned that in, I think it was Cerro Vanguardia, that had underground mining for some veins that are like more deep. Yes, I think mostly of the deposits that I mentioned are use open pits. There's one. No,
Sorry.
well, there's one I can remember now that was mainly subterranean, but there was like a potential open pit. I can't remember now which deposit. Uh, let me see.
Yeah, because quite often mines start from open pits and then they
Yeah.
continue
Reconvert.
downwards.
Yeah, that's the
In-
case in Bajo la Lumbrera. They are in a closure stage where they're doing like studies to see if they can reconvert the mine into a subterranean. They have to see if it's economical viable.
Yeah.
Well, I have it here. It was Cerro Negro that has like 5 underground mines and 1 potential open pit.
Okay. And I also have a question about that mining boom, which you mentioned on Cerro Negro slides, I believe, which started in 1993. So what was the trigger for that mining boom? Change of regulations, or?
Regulations, laws. Ariana mentioned
The change of the mining code, which derivates in a new law on 93. That law gives the companies like a tax and the economy like a stable law, so they can make the activities for over 30 years without changes. That's what primary did.
Okay, great.
There in the chat, Axel just writes, most of Patagonian mines are underground, following low sulfidation epithermal veins, whereas epithermal and porphyry copper gold deposits are usually low grade, high tonnage, and of course somehow shallow for economic viability. Otherwise you have to do block caving, which means huge capex, opex. So yeah, it doesn't the same thing. You have low grade and a high tonnage, so you have to remove a lot of material to get enough concentrate to sell afterwards. I don't know if anyone else has a question. You can write it on the chat, or okay. Well, I'd like to thank Sofia, Ariana, and Daniela for the great presentation that they gave. I'm very proud that you represent us in the world right now, so that's amazing. And also Adam and your colleagues, I really enjoy this activity. I think it's very important to have these cross-cultural meetings and learn about how you relate to mining and culturally, and how can we learn from you that have these older deposits and have a longer relationship with mining, even though we are new to this. And also in in regards to the student chapter, that you have as I told you when we started, you have an established chapter from years before, and we have just begun. So thanks for the opportunity, and I really enjoyed it.
Yeah, me too. It was a great opportunity for us to exchange our, as you said, views. And honestly, I wasn't even aware that Argentina was so rich in mines, and those are quite young mines. So I also really enjoyed this presentation, this cooperation. I'm hoping for more, honestly. So we'll stay in touch, and thank you very much, everyone. Axel and all the presenters. Also, thank you for my colleagues for helping.
But
Yeah.
if you have time, you have one more activities. I have one more activities prepared for this meeting, so if you can stay with us a little bit longer, I have prepared a Geoquiz. I hope that you can have fun and maybe learn a little bit about deposits. So if you have time, I invite you to stay a little bit longer.
Yes.
And so maybe I can share my presentation. Can you see the first slide?
Yes, we do.
Okay, so let's start with some simple questions. There will be just general questions, and if you know the answer, just say it. So, what is the name of this geological feature? Quite famous. Maybe you can recognize it, or maybe you can guess it based on the cities there, or maybe the name.
Bushveld.
Yes, that's correct.
Yeah.
And the next question is, what commodities are mined there?
So I believe chromium, vanadium.
Platinum.
Yeah, platinum.
Yeah. Anything else?
Rhodium, I think. Like
Yeah.
that's a polyform chromite deposit. So we have.
That's correct. There's also some iron, some titanium, but also tin.
Oh yes.
In the middle, there are also granites. So they also mine some tin in this area. But that's very good. So next question. So you see these features in the field, and what types of ore deposit you can expect to find in this area? At least
BMS.
Yes. And the second, maybe in deeper part of these structures, or maybe name these structures. What can you see on this?
Those are pillow lavas.
Pillow lavas.
Exactly. So
Maybe
that's
also
how
like copper, nickel, comatite hosted deposits a couple of
close,
billion
but
years
not
ago.
exactly.
Yeah.
Not exactly. So in the ophiolite sequence, you have VMS at the top, at the border between the basalt, between the gabbro and peridotite. You can also some small accumulation of magmatic sulfides, but you also have podiform chromites in the deeper part of the ophiolite. Okay, so that was the second question. The next question is, try to name, I know at least two well-known deposit types which formed in the past on Earth, but they cannot form today. So try to name these two types of deposit and explain why they can't form right now.
The band iron formations.
Correct. And the second one?
Also the
uranium.
uranium conglomerates on Africa.
Yeah, and why they can't form right now?
Because of the oxygen.
Yes, the oxygenation of the atmosphere. You can have they reduce uranium on continental deposits like conglomerates.
Yeah, but the second one I had in mind is something different, which was not mentioned. Like it was mentioned before, but not in this context. So, can you guess it? It's the comatite nickel copper deposit. But why they can't form today?
It's related to the temperature of the mantle and the core. The same
exactly.
happens with diamond-bearing diatreme and lamprites.
Yeah, that's correct. So basically, the comatite is like high temperature equivalent of basalt, let's say, high magnesium, and it needs a hotter mantle to form. So that's why it could form in the past, but now the mantle cooled and they are not so cold. I think there are some young ones, but it's not so common. Very good. So now try to name several different ways how carbon element can be involved in all forming processes. Like it can be like very wild guesses, like anything goes. Maybe some compounds with including carbon.
Carbon as the element.
It can be part of the chemical compound also. So, for example, I don't know, if you have limestone, you have carbon in it. So, some deposit related to the carbonate rock, like MFT, they can count as related to this carbon. That's the idea behind this question. For example, so some other ways you can think about how the carbon can be involved in, or maybe CO2 can be involved in formation of.
Yeah, so maybe in oil and gas, like you need the like carbon element that it's in plants and animals and everything living to form this. And after the burial and condensating is, you have the ore, let's say, like, the deposit.
And well, usually carbon work as a really good redox trap, especially for highly oxidized hydrothermal fluids. So when eventually they hit a carbon layer, they used to buffer and usually boil out all the metals that are in solution.
Yeah. Excellent. Anything else?
I can think about carbonatites, how they form the carbon, the concentrates on the mantle, on the upper part of the mantle that goes through the big the big faults that can found in cratons, and they can carry the diamonds that form on the rock. Yes.
Exactly. We have like kimberlite. You can also like very high pressure and the gassing of the CO2. Yeah, so that's correct. Anything else you can come up with? Any ideas? I think that's all I had in mind. But yeah, maybe someone else can. Anyway, but okay, that's what I had in mind. So maybe let's move further. The second part is associations. So as an example, when you see emerald, you immediately think about Colombia. It's like very famous country for very nice emeralds. So again, I will show you some pictures, and you need to guess what country is famous for this rock or this mineral. So the first one is this one.
So it's lapis lazuli and Afghanistan?
Yeah, correct. That's a very famous location of this
it's also in Chile. It's not that pretty.
Yeah, very good. So next one.
What
is this one?
Brazil.
That's amethyst.
Brazil, and I don't know.
We have amethyst here in Argentina also. We have it's one of the only deposits that's on the eastern side of Argentina.
Yeah. So I sometimes, because I found this ametrine, so like a mixture of amethyst and citrine, so it was very interesting, like something new for me. So, but it's I think much closer to your country. So and basically the color is due to different oxidation states of iron in this was very good. So next one. This is one.
Australia?
Not exactly. It's called Amolite, and the very famous place for it is Canada, in the Rocky Mountains. Basically, you have ammonite with the opal-like cover. Due to this iridescence, it has this like rainbow colors, and the location is in the Rocky Mountains. So, next one. What is this one?
I don't remember the name of the mineral, but I know that it's from Russia.
Yeah, that's correct. It's través, very rare silicate mineral. I think it was found only in one place, one massive in Siberia, and it has very complicated structure. And it took a lot of time to many crystallographers to figure out what is the exact structure of this mineral. Okay, so let's move to the next part. So basically, I will show you some pictures, and based on these pictures, you need to guess the name of the element, but you do not tell the name of this element, but say the name of minerals which contain this element. So let's start with the first one.
I mean, like cinnabar.
Yeah. Correct.
That's the only one I know. That's the most common, the only one I know.
Yeah.
There's one like Plinio, something like that. That's the oxide, I think.
Yeah, but there's also one mineral you can even see on the picture in the right lower picture.
These are just like basic mercury.
Native mercury.
Native mercury. Okay, so the next element.
All right. We have calaverite.
Yeah.
We have native gold and
Electrum.
Yeah.
electrum.
Petsite, for example, some tellurite. So
Pyrites, maybe?
Pyrite.
Not exactly. You can have like gold-bearing
It's
pyrite,
related.
but it's not gold mineral. But yeah. Okay, so let's move to the next one.
All right.
Okay.
Sphalerite. Germanium bearing sphalerite.
No, but let's try to think about some germanium-bearing minerals.
That's cheating. That's your specialty.
For example, Germanite. It's quite easy. Germanite. It could be renierite, briartite. There are some germanium sulfide. Okay, so how about this one?
Okay. You have hematite, magnetite.
Siderite.
Yeah.
Pyrite,
Pyrite.
Correct.
marcasite,
Yep.
chromite.
Basically, you can name so many like silicates, sulfides that this will be very, very long here. Okay, so now the last question. I will show you 4 pictures, and you need to guess the deposit or like mining region based on these 4 pictures. It will be similar to the previous one, but this time we are talking about mineral deposits or mine. Or maybe not. This is the next one. So first, sorry, my mistake. So let's try to name the major countries producing given elements. So let's first start with silver. Let's try to name 10 biggest silver producer countries.
Bolivia.
Poland somewhere there.
Chile.
Mexico, Peru.
South Africa.
Yeah.
Canada.
South Africa,
Indonesia.
not there. Canada is not there. Indonesia is not there.
China.
Yeah, just China, yeah.
Sweden?
Not,
No.
not on my list, at least. Okay, so the data came from World Mining Database, and it looks like this. So Mexico is number 1, and Peru, China, Russia, Australia, Chile, Poland is there, and also Argentina is there, so number 9, at least according to this data for 2019. The next commodity is palladium. Try to name 3 biggest palladium producing countries in the world.
Russia.
South
Right.
Africa.
Correct. And the third one?
And Canada also.
Correct, yeah. Russia, South Africa, and Canada. And these two are the biggest producers. The next one, so we have palladium, now platinum.
I guess
Canada.
also South Africa.
Correct?
And Canada.
Not
Nope.
this time. No Canada.
Russia maybe, or China.
Russia, correct. Russia, no China. Maybe a little bit surprising, but Zimbabwe is the third biggest producer of platinum. Canada is number 4. Okay, next one. 3 biggest rhenium producers.
Well,
China.
Maybe,
I have to go with South Africa.
no, but maybe as a, I will help you a little bit. So the main source of rhenium are porphyry copper moly deposits.
Poland.
Maybe Chile.
Poland is correct. Chile is okay. And the third one?
Maybe Peru.
Peru.
No, Peru, not Peru.
The U.S.
Yeah, correct. It's US. So 2020, there's Chile, Poland, and
You search for
United
it,
States.
Pablo.
I'm not using Google. I'm not using Google.
Okay. So next one. Name 4 biggest rare earth concentrate producing countries in the world.
China.
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 But
Sweden.
that's easy. Sweden? No, Sweden.
Does Russia?
Argentina.
No,
Germany.
no,
Africa,
no.
South Africa.
Okay.
The U.S.
Oh, Africa.
US is correct.
Australia.
Correct. And the 4th one, it will be also tricky. I can tell you that. I was surprised when I saw the 4th country. So it's Myanmar.
Oh.
This in 2019. So, and the last one, it will be quite easy. What are the 4 biggest lithium producing countries? I think I saw it on one of your slides.
Argentina, Bolivia,
Argentina, Bolivia,
And China.
Chile.
Chile.
And Australia.
Australia, Chile, China, and Argentina. Okay, so now this is the one I told you earlier. You need to guess the deposit type, name of based on the pictures. I will show you 4 pictures, but you can guess earlier. If you guess after the first picture, you get 4 points, but no one will count these points, so it's just for your personal glory. So let's start, and you will just after the first one you will see how it's going. So the first picture for 4 points. Yeah, but you need to name the exact deposit or district. Maybe the third one.
Bingham.
Yeah, Bingham Canyon in Utah, very famous open pit with porphyry copper deposits. And porphyry, Bingham, and Canyon here. Okay. Next one.
Olympic Dam.
Olympic Dam.
Correct. Yeah, that was easy. Olympic
ILCG.
Dam, ILCG, and Australia. That was easy. So let's move to the next one. How about this one?
Mississippi. MBT. No.
Mississippi Valley.
Now there are already 2 pictures, so maybe the third one.
We don't see the second picture, I believe.
You see, I'm sure you see it. And now the fourth picture. Maybe I will tell you that it's located in South America, and the name is in Spanish.
Río Blanco?
Exactly, yes. Rio Blanco, Los Bronces. I found that Los Bronces, I think it means brass.
Yeah.
So it's like the mixture of copper and zinc. So it's a huge porphyry system in Chile. But it was basically Rio Blanco and the picture of the mine. Okay, so the next one. What about this one?
Horn.
Horn. Close.
Buffalo. Okay.
Yeah.
Band iron formations.
Yeah, but name of the deposit.
Kryvyi Rog. I don't know. In Ukraine.
Kryvyi Rih. Basically, it means like a bended horn in Ukrainian. Bended, curved horn, and the famous bent iron formation, Precambrian age there with layers of magnetite and hematite, and it's like bended horn. This is the symbol of this city there, of course, Ukraine, and the bended iron formation. Okay, so how about next one?
No, that's
Bear.
Red Dog.
Yes, that's correct. It's a Red Dog in Alaska, very famous zinc mine, and basically you have last frontier is the nickname of this Alaska state. This you have zinc, Soviet dog, so Red Dog, it's FedEx, and Red Dog. That was easy. Next one.
Broken Hill.
Broken Hill.
Yeah, that was also easy. So DHP, the deposit is famous for the garnets and galena. Australia, of course, so it was also pretty fast. So how about next one? This will be tricky.
Split.
That's Moses.
Yeah, no, yeah, but it's not that important in this picture. What's behind him is more important, I'd say.
Oh, that's where the vanadium is in South Africa.
Oh, South Africa.
It's the Red Reef. No, I don't know the name.
Something reef.
Yeah, so basically, it's
Whitewater.
Waterstrand. And it means in Afrikaans it means reach of white waters. So very famous concept. Basically, reach of white waters. Like literally, in the picture you have reefs, gold reefs, but this is just a reef, and you have South Africa and gold. So, next one.
Green.
Grasberg.
Yeah, Grasberg. So it's very famous porphyry and skarn copper deposit in Papua. And you have grass, you have a berg, so it means mountain in German means berg. And you have Papua, and famous for the birds of paradise. Okay, how about this one?
Is curling?
Yeah, I think maybe I heard it already.
Is
Caroline.
Yeah.
Carling gold pipe.
Yeah, carving type gold deposit in Nevada. Basically, you have Carling, you have guy who his name is George Carlin. You have Car and you have Line. Carlin. Car was very popular in Poland in the past, and you have Las Vegas, Nevada. How about this one? Any guesses?
Are you sure these peaks are related?
Of course. Okay, so Mirny mine in kimberlite pipe in Siberia. So this is space station Mir, Siberia.
Yeah, of course.
This is in Russian, Mir means peace, but also means war. That's why it's like a dove.
My Russian is pretty
war
rusty.
in the background.
Sorry.
And you have basically diamonds. So that was the association. How about this one?
Well, Franklin.
Yeah, but there are like two names, two words in the name of this deposit.
Franklin Sterling.
Sterling.
Yeah, correct, yeah. Basically, Franklin Sterling deposits in I think New York State, in US. They're very famous for the fluorescent minerals. They're metamorphosing deposit, and you can see this glowing heaps and also corridors. They're like zincite, brucite, and some other minerals. And Benjamin Franklin, you have Sterling, you have pound sterling, and you have the cartoon, and this character is named Arthur Sterling, and you have this fluorescent minerals from there. Okay, how about this one? This is the first one.
Sumer?
Also quite tricky.
This is from this is the one from Namibia, isn't it?
Yeah, correct. Yeah.
What's the name?
Something with a pipe.
yes, the deposit has a shape of a pipe, so it's not in the name, but the pipe shape.
Numel? Can it be Namel?
Yeah. How about the right top picture?
Sumer?
Exactly, Sumer.
Yes.
Oh,
Yeah. Famous deposit with germanium, with many rare and very nice crystals found there, and you have pipe. You have the guy who wrote this, the article was Sun Tzu, and so Sun is crossed, he said Tzu map, and this is very famous dioxide from this mine, and this is Germanite, and GE is for germanium. So I think that was the last one. Yes, so that was it. I hope you had fun. Maybe learned something new.
yeah. Thanks a lot, Chris, for this.
Very entertaining
Yeah. It
and
was.
funny.
I have to practice my Russian.
Okay, so
We
that's
had
everything from me.
we had one. We managed to do one riddle. I don't know if Sophia wants to show.
Yes, I will show it.
It's just one, and it's very simple, but well, it's something. And it's very easy, so I don't know the next one. No, that one. Well,
Belt.
we mentioned it in the presentation, and this one is in English. The next one is the same, but in Spanish for our Argentinian friends. No.
It's a belt of something,
Yeah.
but
It's the India belt.
The India belt.
India belt.
India means
Okay.
like, yeah,
Native.
native. And that's for like our Spanish. Well, that was it.
What is this?
It's the same.
This is it's a singer.
It's a singer.
Indio.
It's a very famous singer here in Argentina. It's called
He's
El
called
Indio
Indio.
Solari.
And the thing that it's faja del indio in Spanish is indio belt. Well,
Okay.
that's it.
All right. Thanks a lot for everything, for the presentations, for entertainment section. Yeah, I believe we will appreciate it, and I don't know. I guess what has a start, it has an end. So
Great. We hope we can do this often. You know,
Yes.
make
Yeah.
activities.
For sure.
yeah.
That's great. And thanks. I want to thank the people that came to see this meeting. All that are there in the 14 of us. So
Yeah.
it was great. It was very, very, very good. Thanks a lot.
Yeah.
Thank you so much.
Thank you very
Thank
much.
you.
And bye bye. Till the
Bye-bye.
next time.
Bye.
See you
Bye.
next time.
See you.